Rust or corrosion is a natural electrochemical process that causes metal deterioration when exposed to water, oxygen, or chemicals. This study tests the effectiveness of cooking oil as a protective coating and by exposing metal samples to indoor and outdoor environment, both with and without oil. The goal was to compare corrosion rates and assess how environmental conditions influence protection.
Corrosion is a natural process that damages the metal when exposed to moisture, oxygen, or chemical. This project explores how different environment, which is indoor or outdoor, affect the rate of corrosion on the metal samples. We also test the effectiveness of cooking oil as a simple coating to prevent or slow down the rust. As we combining the result, we aim to find a practical way to slow the corrosion or protect the metal structure.
2.0 objective. First, to observe and compare the rate of corrosion on metal sample under different environmental conditions, which is indoor and outdoor environment. Second, to evaluate the effectiveness of a protective coating used a cooking oil in preventing or slowing down corrosion. 3.0 material. First, material cutter knife 80 mm. Equipment, first container, second cooking oil, and third marker.
Nampak ada 1, 2. Yang tu keluarkan semua yang tu. Okey lah tu. Untuk indoor.
So I forgot to mention that these two samples are for the closed environment, and today is our observation. That's all.
Today is day 8 observation. Compared to before this, day 6, coating sample changes. Like untuk coating have some changes, which is
The rust is spreading due to the environment factors that also triggered the oxidation process and reaction with oxygen and form the iron oxide, which is cause rust.
today is the final day of observation before we write the report, which is this day is day 14 of the experiment.
Saya tak belakang.
First, we go to the outdoor environment sample, which is coated sample. We can see the small amount of rust in the surface, and the back sample we have the line shape corrosion pattern.
Okay, pusing.
For the uncoated sample, we can see more rust compared to the coated sample. This is because the material is fully exposed to the environment without any protective layer. The rust spread quickly and widely across the surface.
No significant difference in corrosion was observed for the uncoated sample compared to day 12 under indoor condition.
On day 14, no significant difference in corrosion was obvious for the coating sample compared to day 20 under indoor condition.
Okay, after 14 days of observation, we can clearly see that the outdoor sample develop significantly more rust compared to the indoor sample. Interestingly, in both environment, the coated sample show noticeably less rust formation than the uncoated sample one. In terms of corrosion type, the outdoor coated sample had crevice corrosion, while the uncoated outdoor sample show uniform corrosion, which spread evenly across the metal surface. Meanwhile, the indoor surface show only slight rusting, which based on outdoor observation could be pitting corrosion, a type of localized corrosion that forms small hole on the metal surface.
In this experiment, we observe how different environment affect the corrosion of metal over 14 days. We test coated and uncoated metal sample in both indoor and outdoor setting. In the closed environment, corrosion was minimal, especially on the coated sample, but in the open environment, the uncoated sample rose quietly, while the coated one show rose only in a certain area. They show that cooking oil can slow corrosion, but is not acceptable for long-term protection outdoor. Stronger coating area need for real-life application. In this experiment,